Now got a red light.
My name's Jay Hafner, and you all have heard a lot of videos from me. You've seen a lot of stuff through the retrofit of the Kennex, but we have a real blessing right now. We have a visitor. His name is Bruce Wilson, and you'll know more about him in a few minutes. But basically what we're going to do is show you what the first production catamaran with electric propulsion from Dave Tether's design that started this whole process. And that was back in a few years back. Bruce will explain the whole details on that. But he's come to Marathon, Florida, in Marathon Marina and Boatyard to visit us and to help us with the final days before the Miami Boat Show and Strictly Sail. So here's the rest of it. Stay tuned. Enjoy the video.
And I'm producing all this excess power. The longer you sail, the more you enjoy that, because I've got a 400 gallon a day water maker, refrigerator, freezer, everything runs permanently. And you know, at times you can produce so much power that you just leave the water maker running and hose the deck off while you're at sea. Where normally the limitations for cruising people, you know, with the advent of electronic navigation, etc., that took a lot more people onto the water. This fear of having to do celestial navigation and have a guess, I'm somewhere within 10 miles of where I think I am, to accurately placing you within 13 feet. The next, and then marinas improved dramatically all over the world. But the normal limitations to people are then how much food, how much fuel can I carry? Because on the average boat, that's just got diesel generator, etc. Now, for their refrigerator or their freezer, and however ergonomically they go, if they're going to go sailing for 3 months and be off the grid, anchoring out, things like this, then they're typically running their generator an hour a day. Well, part of the solution to that has been provided with solar panels, part with wind power, but they're still running their generator, so it does become an equation of fuel. Me, I don't need to worry about that. I produce as much power as I want just sailing the boat around. I've got 400 watts of solar panel across the back of the boat. That's more so that if I'm sitting at anchor for a month, that keeps up with my refrigerator and freezer. And that's when we go back to cooking with propane. But propane produces heat inside, and
yes.
So I tend to avoid that. There is the biggest plus though, is that instead of being fuel dependent, which is the current dependency of most sailing vessels, how long they can stay off the grid, away from somewhere, is how long will their fuel last. So we don't have that problem. Our problem has now become how long will the food last. Well, we've got quite a big freezer, so we can carry about 3 months of food on the boat. And then if we have any luck fishing, we can last even longer. So it's taken one more piece. Having the electric drives has taken one more piece out of the equation of how far can you go and where can you go.
And how comfortably you can get there.
And well, how comfortably you live along the way. And us being a little older, we like our creature comforts.
Now, one of the things that people are concerned with is they see the electric motor, they don't understand it. You know, simplicity is brought into play here. But you have one of the big things that I see is the biggest change in the noise level of the boat. When you're motor sailing with a diesel engine, it's a very loud process.
We're quieter, yes, but you've got to remember, if I'm motor sailing long term, if I'm not just getting on and off the dock, then I am running the generator. And so, you know, the generator's in an enclosure. I would say that the generator is, compared to current day installations, not a lot quieter than what you would find running one engine. I don't look at that as being, you know, this quietness as being a plus or a minus. I've got to tell you, the biggest plus out of the electric drive system, it's idiot proof. It's got 2 moving parts. That's 2 bearings that have to be replaced every 100,000 hours. You know, so consider that you sailed you look at it, normal work week, 40 hours, 50 weeks a year, that's 2,000 hours a year. That's 50 years motoring before I have to change the bearings. I'm sorry, but I've got to actually change the stuffing in my stuffing box a bit more frequently, and I've got to change my strut bearings a bit more frequently. But from the engine side, no maintenance.
Now, you made a comment on you can control the amount you generate
Yeah.
with your throttle position. Would you explain that?
Okay. If I leave the engines off while I'm sailing, the props will spin.
Right.
So you're looking at the back EMF of the motors, because the motors being end-magnet, in terms of having it doesn't have a field winding, it's got magnets. So you've only got the rotor winding. So you've now got that normal feel when you turn a generator, and you can feel the resistance because you're generating power. If I just touch the throttles a hair and bring myself up to using about 1 amp, well, now all of a sudden I've sort of overcome that initial inertia, and all of a sudden I start generating 3 to 4 amps. So you sit here watching the amp meters. As I'm going up a wave, they'll go negative because they're pushing. As I'm going down the wave, they go positive. And I can have them sit there where they only go negative for about 1 amp, positive for about 4 or 5, both of them. So I kind of look at the averages and go, I know, because I've done it. I've sailed the boat, over 24 hours without having to start the generator to charge the batteries, and kept the batteries fully topped up and produced excess power. Because you have a look at the power panels down there, you'll see that I've got a lot of current metering to see where the current's going.
So what you're doing when you're doing that, though, you're not really using the motors for power, pushing you hardly at all.
Dave calls this regeneration mode, where you're really using them to push you up a wave, generating going down. Well, you can play with that. It depends on how much you want to use in terms of the push up, and how much you want to use, and how much you want to generate coming down. Because I find that I can comfortably generate 4 to 5 amps in 15 knots of breeze. And so do I want to use that whole 4 or 5 knots pushing me up waves? If I did, I would go a touch faster. But you've got to deal with the normal resistance of the boat, just going up a wave. So I don't find that it cheats much in terms of sailing speed. I'm more interested in producing the power, therefore not having to run the generator.
Well, what happens if you leave your throttle in neutral?
If they're just in neutral, I tend to produce a little bit more resistance. I still generate, but I don't generate quite as much. So, don't ask me the good reason for this, but once the motor gets engaged, it seems like there's this just initial resistance to getting it going. So I actually end up generating more by having the motor just engaged, 1 amp or less per engine, than if I've got them sitting in neutral where I'm generating nothing or using nothing.
Now what happens if you shut the power off to your motors? You have an on-off switch, right?
Yeah.
Now if you shut that off when you're sailing, what happens?
Well, now the spinning of the props is just producing back EMF against the motors. It's just drag like you have on a regular boat with a normal motor, unless you've got feathering props.
But it won't hurt the motor.
No. You're not going to blow anything up.
As unlike some transmissions that if you motor, you'll actually hurt them.
Yeah.
Just another plus for the electric drive.
Yeah. This technology has been around for about 10 years, and it is improving. But is there a lot on this boat that I've had to turn around and go and change? And the answer is no. There's some things that people hadn't thought about, that having the experience of having the boat, one of the things that I put on, if in winter we don't use the boat for 3 months, and I accidentally leave something on, like a fan, a 110 volt fan, that could slowly bleed down my 144 volt battery bank. Just so it doesn't go flat, I've got a battery protect that is between 2 of the batteries. If it gets to 12 volts, it opens up the battery bank to stop it from going below 12 volts. That's a simple little safety device for when you're leaving the boat alone. Things like that I've done that I haven't seen anyone else do, but that's more a little bit of having played with the boat a lot and going, oh, I wouldn't want that to happen. And when you've got one of these, you tend to think about, what could go wrong.
Yeah.
And what I've determined is, I mean, in terms of Dave's design, that's the only piece I've added to his design. it's something that, no matter what, if you're off the boat, you're not going to kill your batteries. So, but the rest of the design is exactly as he designed it. What I've put on the boat, though, is more, since this boat came out of charter service, it came with no electronics. There was no chart plotter, 3 of the gauges, all the instruments on the nav station.
She's also put in a 6.5 dimension Sensata inverter.
Yes.
And which runs all his AC and all his 110 loads, air conditioning and stove and everything else when he's
that came
running.
From Dave. And I'll tell you, when I got my inverter, it had a problem straight out of the box. Instead of running at 60 cycles, it was running at 120. Called the manufacturer. They were like, "Can you look at the waveform?" Yes, I could. Told them what it looked like, sent them an email with a picture, and they said, "Pack it up, ship it back." They paid the freight. I had it back in less than a week. Just brilliantly happy with their customer service. But in talking to them, discovered that they make these inverters for toxic chemical environments. And when you look at the circuit board, it has got a 1/16 to an 1/8 of an inch of epoxy coating over everything. There is nothing you could get in there and repair. It is 100% coated. It is perfect for a marine environment. Very happy with that. The original 10 years ago, Dave had a battery charger that wasn't very 110 volt battery charger, 120 volt battery charger for the 144 bank that was heavy, only charged at 6 amps. That got changed out to the one he's currently supplying with the boats, which is a 20 amp charger. Very happy with. Another thing that he recommended that we took, Victron make a 12 volt charger. So my house battery is still only 110 amp battery. I don't need any more. My real house battery is a 144 volt battery bank, because my 12 volt charger is 90 to 265 volts, 50 or 60 cycles, AC or DC. So if I'm on the dock, I can put that in and charge my battery. It cross charges from the 144 volt bank over to the 12 volt. So the 12 volt battery is really a float battery. That means I don't need a big house battery. And when that one dies, I'll go back and put another Odyssey in. That's the last lifeline on the boat. And I'll take that extra weight out and just put an Odyssey back. Very happy with how that works. So there's not... There's some strange things, not to do with the electronic drive, but to do with grounding systems and stuff like that I ended up putting in isolation. But that was to do with the fact that the boat was wired, single sideband radio, traditional grounding system. And if you looked at this boat and said, okay, my 144 volt battery bank with my generator, my inverter and my engines is really a giant UPS that you use on your computer. Power fails, the battery keeps your computer running for 15 to 20 minutes while you close everything down. Okay? Well, that's how you need to, in my opinion, how you need to treat this as a giant UPS. So when I plug into shore power, all I'm doing is charging that battery. I pull power off that. So I tend to run a lot with the inverter and just pull power.